Control valve specification. 1. Introduction. This specification outlines the minimum requirements for the design, selection, manufacture, assembly, testing, inspection, and delivery of control valves for industrial applications. 2. Codes and standards. The equipment shall be designed, fabricated, and tested in accordance with the latest revisions of relevant international codes and standards, including ANSI ISA 75.01, flow equations for sizing control valves, ANSI FCI 72, control valve seat leakage, IEC 60534, industrial process control valves, NACE MR0175, materials for use in H2S containing environments in oil and gas production, ASME B16.34, valves flanged, threaded, and welding end. 3. Design and selection requirements. 3.1 General. Control valves shall be designed for a minimum life of 25 years. All materials and ratings shall comply with relevant piping and instrumentation data sheets. Control valves shall be factory assembled, tested, and ready for installation. 3.2 Valve body selection. Types: globe, cage type, rotary, eccentric plug or segmented ball, butterfly, single or double seat globe, ball. Materials: suitable for H2S service, complying with NACE MR0175. Sizes: standard sizes from 1 inch to 12 inch, unless specified otherwise. Flanges: ASME class rating as per piping class, minimum 150 pounds. HAS 3.3 valve trim, minimum SS 316L, with options for stellite or other hardened materials for erosive services. Characteristics: linear for level control and gravity service, equal percentage otherwise. Quick open trims for on-off valves. Leakage: maximum allowable seat leakage as per ANSI FCI 70.2, typically class 4. 3.4 Bonnet and packing. Bonnet: extended bonnet required for temperatures below 32 and above 200 degrees Celsius. Packing: PTFE for services up to 230 degrees Celsius. Graphite laminated for temperatures up to 540 degrees Celsius. 4. Types of control valves. 4.1 Globe valves. Applications: suitable for high-pressure drops, precise control. Design: cage-guided, single or double-seated. Size: 12 to 400 millimeters, larger sizes available. Characteristics: versatile, turn-down ratio up to 51. 4.2 Rotary valves. Types: eccentric plug, segmented ball. Applications: general purpose, cost-effective. Size: 25 to 300 millimeters. High CV values, turn down up to 125 to 1. 4.3 Butterfly valves. Applications: low pressure drop applications. Size: 2 to 120 inches. Characteristics: lightest valve, turn down up to 75 to 1. Limitations: not suitable for high pressure drops. 4.4 Ball valves. Applications: high turn down, suitable for abrasive services with ceramic materials. Sizes: 10 millimeters to 500 millimeters. Characteristics: turn down up to 500 to 1 for V-ported valves. Limitations: not recommended for slurries, high-pressure drops. 5 Actuators. 5.1 Diaphragm actuators. Type: spring return, nylon-reinforced neoprene or Buna-N rubber diaphragm. Material: steel or cast aluminum housing, open yoke for packing adjustment. Force: sufficient to fully stroke the valve under maximum differential pressure. 5.2 Piston actuators. Application: long stroke or high thrust requirements. Design: double acting with external volume tank and trip system if specified. 6 Accessories. 6.1 Positioners. Type: smart positioners with Hart protocol, stainless steel construction. Capacity: sufficient for pressuring and venting the actuator, weatherproof, IP66. 6.2 Solenoid valves. Material: 316L SS body, resilient material for seat. Installation: between positioner output and actuator, explosion-proof, XD, IP66 rated. 6.3 Air filter regulators. Type: 316 SSL, reducing relief valve type, 25 mm mesh size or less. Installation: on actuator with stainless steel pressure gauge. 6.4 Quick exhaust valves. Application: for services requiring fast opening or closing. 6.5 Hand wheels. Requirements: operating torque 80 mm, yoke mounted, non-declutchable. 7. Installation and commissioning. Control valves shall be installed as per manufacturer recommendations, ensuring accessibility for maintenance. All tubing and fittings for air supply and control signals shall be stainless steel. 8. Inspection and testing. Inspection: in accordance with the inspection test plan, testing, functional, actuator, and leakage tests as per standards. Reports, detailed test reports to be provided with each valve. 9. Packaging and shipment. Packaging, valves to be securely packaged to prevent damage during transit. Marking, stainless steel nameplates with relevant valve information. 10. Documentation. Supplier documentation, as per supplier data requirements list. Spare parts, 2 years operating spare parts list to be provided. 11. Valve sizing and selection. 11.1 Sizing standards, control valve sizing as per ISA IEC Criteria, maximum flow, valve opening 80 to 85%. Normal flow, valve opening 40 to 60%. Minimum flow, valve opening 20%. 11.2 Pressure drop considerations. For high pressure drop applications, consider angle body valves or low noise labyrinth trims. Ensure valve can handle 150% of normal flow or 110% of maximum flow, whichever is higher. For two-phase flow, consider CV for both liquid and vapor phases. 12. Noise and cavitation control. 12.1 Noise control. As per IEC 60534-8. Limits. Noise level 85 dBA at 1 meter from the valve. 12.2 Cavitation and flashing. Avoid cavitating and flashing surfaces through proper valve selection and sizing. Use hardened trim materials like stellite for erosive surfaces. 13. Environmental and safety considerations. Valves must meet site-specific environmental conditions. Hazardous area classification and ingress protection must conform to IEC 62529 IP66 standards. Conclusion. This comprehensive specification ensures that control valves meet rigorous standards for performance, reliability, and safety in various industrial applications, covering all technical aspects of design, selection, installation, and testing. Control valve selection for various applications. Detailed technical and practical aspects. Selecting control valves involves considering multiple factors such as the type of fluid, operating conditions, and specific process requirements. The ISA, International Society of Automation, codes and standards provide comprehensive guidelines to ensure optimal valve performance and reliability. 1. General selection criteria. 1. Fluid characteristics. Viscosity, corrosiveness, toxicity, phase, gas, liquid, multiphase, and particulate content. 2. Operating conditions. Pressure, temperature, flow rate, and differential pressure. 3. Process requirements. Control range, response time, shutoff requirements, and safety considerations. 2. Pressure control. Example, process gas compressors, type of valve, pressure control valve, PCV. Design considerations, body material, carbon steel for general applications, stainless steel for corrosive environments. Trim material, hardened stainless steel for durability against erosive wear. Valve type, globe valves are preferred for precise control. Ball valves can be used for high flow applications. Actuator type, pneumatic diaphragm actuators for precise control, electric actuators for remote operation. Flow characteristics, equal percentage flow characteristics to handle varying pressure drops efficiently. Sizing, correct sizing using ISA standards to ensure the valve can handle maximum and minimum flow rates without instability. Positioners, digital positioners for accurate and responsive control. Safety, ensure fail-safe position, fail open or fail closed, as per the process safety requirements. 3. Flow control. Example, crude oil pump discharge to export pipeline. Type of valve, flow control valve, FCV. Design considerations, body material, carbon steel or stainless steel depending on crude oil properties. Trim material, tungsten carbide for erosive surfaces. Valve type, globe valves for fine control, rotary valves e.g. butterfly or ball valves for higher flow capacities. Actuator type, electric actuators for high torque requirements, hydraulic actuators for reliability. Flow characteristics, linear or equal percentage to maintain stable control across varying flow rates. Sizing, accurate sizing based on maximum and minimum flow rates as per ISA standards. Cavitation and flashing, anti-cavitation trim or multi-stage trim to prevent damage from cavitation or flashing. Positioners, use of smart positioners for enhanced control and diagnostics. 4. Temperature control. Example, oil heater, Type of valve, temperature control valve, TCV. Design considerations. Body material, suitable for high-temperature applications, typically stainless steel or special alloys. Trim material, high-temperature alloys to withstand thermal stresses. Valve type, globe valves are preferred for precise temperature control. Actuator type, pneumatic or electric actuators depending on response time and control requirements. Flow characteristics, equal percentage flow characteristics to ensure stable temperature control. Thermal insulation. Valves may require insulation to minimize heat loss. Sizing. Ensure correct sizing based on heat transfer requirements. Temperature sensors. Integration with temperature sensors and controllers for accurate feedback and control. 5. Level control. Example, crude oil tanks, slug catchers, three-phase separators. Type of valve. Level control valve, LCV. Design considerations. Body material. Depending on the fluid, carbon steel or stainless steel for tanks. Special alloys for corrosive environments in separators. Trim material, hardened materials for wear resistance. Valve type, globe valves for precise control, diaphragm valves for corrosive or slurry applications. Actuator type, pneumatic actuators for reliability and fast response. Flow characteristics, linear or quick opening to handle large level changes. Sizing, correct sizing as per ISA standards based on vessel dimensions and level control requirements. Positioners, digital positioners with feedback loops for accurate level maintenance. Redundancy, consideration of redundant systems for critical applications to ensure continuous operation. Safety, fail-safe positions, fail open or fail closed, based on process safety analysis. Detailed considerations and best practices. 1. Material selection. Choose whose materials based on the chemical compatibility with the process fluid. For sour service, NACE MR0175's ISO 15156 standards provide guidelines for material selection to resist sulfide stress cracking. 2. Valve sizing. Utilize ISA 75.0101 standard for valve sizing equations to ensure the valve can handle the required flow rates and maintain control stability. 3. Trim design. Select appropriate trim designs, e.g., low noise trim, anti-cavitation trim based on the process conditions to minimize wear and noise. 4. Actuator sizing and selection. Ensure actuators are properly sized to handle the valve torque and thrust requirements. Consider the fail-safe position and environmental conditions, e.g., explosion-proof actuators in hazardous areas. 5. Positioners and controllers. Use smart positioners and controllers to enhance control accuracy, provide diagnostics, and facilitate maintenance. 6. Installation considerations. Ensure proper installation to avoid stress on the valve body, provide adequate support, and allow for easy maintenance access. Follow ISA 75.9.01 standard for control valve mechanical installation requirements. By following these detailed criteria and considerations, you can ensure the optimal selection and performance of control valves for various applications in gas, water, crude oil, and process gas systems.